Sun has always held a very important place for humans. Sometimes it was seen as a god, sometimes a guide, and sometimes a magnificent structure that warms your heart and lets you feel peace deep within. The sun and the solar system have been the main focus of scientists' research for many years. Even though these studies provide us with very clear and definite information, they can also become quite confusing after a certain point because so many theories have emerged. Today together we will talk about one of these theories. This theory suggests that the sun was not actually alone when it first formed and that it once had siblings beside it. Before we move on to our video, don't forget to subscribe to my channel, like my videos, and support me by sharing your thoughts in the comments. Now, if you're ready, let's begin our video. In a dark and remote corner of the universe, about 4.6 billion years ago, a gigantic molecular cloud of gas and dust slowly began to collapse into itself. In fact, this cloud was not ordinary. It contained hydrogen, helium, and heavy elements left behind from the explosions of previous generations of stars. These elements were actually extremely critical for millions, even billions of years into the future. Thanks to these elements, life emerged on planets and continued for a very long time without major interruption. Later, the shockwave from a supernova explosion compressed this giant molecular cloud, and gravity came into play. As the gas and dust collapsed inward, the temperature and pressure in the center increased. Astronomers call this stage the protostar phase. When the core temperature exceeded 10 million degrees, there was no turning back. As hydrogen atoms began to fuse together, nuclear fusion had physically begun. The clouds we mentioned at the beginning are also known as stellar nurseries, and these regions produce stars in extremely dense numbers. In our Milky Way galaxy, there are still such stellar birthplaces, and one of the most popular ones today is the Orion Nebula. Our sun was born in such a star-forming region. Many people romanticize the process of star formation and describe it as if it were a perfectly functioning system, but the truth is that this process is extremely violent, chaotic, and dominated by the ruthless force of gravity. Anyway, the shockwave of a supernova explosion, or a galactic density wave, compressed a portion of this molecular cloud, and then the density gradually increased. At the same time, gravity pulled the gas even more toward the center, and as the collapse accelerated, the temperature at the center increased. This chaotic process is actually the formation stage of the protostar object I mentioned briefly earlier. During this stage, our sun had not yet been born. When the temperatures at the center reached tremendous levels, about 10 million Kelvin, hydrogen nuclei began to fuse together, and the reaction process known as the proton-proton chain began. 4 hydrogen nuclei combined to form a helium nucleus, and a small portion of the mass was converted into energy according to Einstein's formula E equals mc squared. And finally, the most important point and object for both us and the entire system was born, our sun. This birth changed many things. Most importantly, it triggered the existence of us, in short, life itself. If our sun had not existed, life either would never have emerged or it would have been very different from what we know today. So, was the sun alone when it was born? The main reason we ask this question is that the vast majority of stars in the universe are not born alone. Studies and statistics show that a significant portion of stars, especially those with masses close to that of the sun, form in binary or multiple systems. More importantly, stars are not born individually, but in clusters. These facts and the ideas emerging from them greatly reduce the number of people who believe the sun formed alone. Moreover, these clusters can contain anywhere from a few hundred to several thousand stars. One of the best modern examples of such clusters is the young open cluster Pleiades, also known as the Seven Sisters. All of these stars are born from the same gas cloud, and their chemical fingerprints are similar. Their ages are also the same. In short, they always have a connection with one another. During the early years of their formation, the distance between them might not even be a few light years. In other words, when viewed on a cosmic scale, these stars appear almost shoulder to shoulder. By the year 2014, a Dutch astrophysicist named Simon Portegees Swart and his team began a very interesting study and modeled the properties of the cluster in which the sun was born using computer simulations. As a result of their studies, they revealed that our sun may have been born in an open cluster containing approximately 1,000 to 10,000 stars with a diameter of a few parsecs. In such a crowded environment, close encounters between stars are possible, and these encounters can shape planetary systems. Many people in the scientific community opposed this idea and argued that the studies did not reflect reality and that significant mistakes were made during the research process. However, the theory I just mentioned is not based solely on statistics or on a superficial study. The evidence actually comes directly from meteorites themselves. In some meteorites that fell to Earth, scientists discovered short-lived radioactive isotopes. In particular, elements such as aluminum-26 and iron-60 greatly surprised the scientists conducting the research. The presence of these isotopes indicated that a supernova explosion had occurred near the environment where the sun was born. This is because such heavy elements are produced only by the explosions of massive stars, and they decay within relatively short periods of time. This actually tells us something very important. The sun was not born in an isolated corner, but rather in a large and active star-forming region. The youth of our sun was not calm like it is today. It was in a phase called the T Tauri stage, and during this stage, stars exhibit extremely intense magnetic activity. powerful X-ray flares, dense stellar winds, and irregular brightness variations occur frequently. These violent stellar winds also shape the gas disk surrounding the star. The protoplanetary disk that formed around the Sun had a width of roughly 100 astronomical units. Dust grains within the disk began to stick together through electrostatic forces, gradually forming millimeter-sized particles, then centimeter-sized ones, and eventually reaching meter-scale objects. After that, a force that is vital for us, gravity, came into play. During these stages, the region resembled complete chaos, almost like a battlefield. Later, kilometer-sized planetesimals formed, and the collisions between them were extremely violent. As we mentioned, the young solar system was practically experiencing a war. These collisions gave birth to planetary embryos, and in the inner regions, Mercury, Venus, Earth, and Mars formed. In the outer regions, gas giants such as Jupiter and Saturn emerged. The formation of Jupiter was actually far more important than previously thought. In fact, the main reason the solar system is relatively calm and stable today is Jupiter. Thanks to its powerful gravity, Jupiter radically changed the dynamics of the system. It scattered smaller objects toward the inner solar system and even influenced the paths of comets that brought water to Earth. This means that if Jupiter had not existed, even if the planet Earth had formed, it might not have contained water or life at all. At the same time, Jupiter also ejected many large and small objects out of the solar system into interstellar space. Some of these ejected bodies may have traveled toward the stellar systems of the Sun's sibling stars. The real critical question starts here. Where are the Sun's siblings? In the modern age of data, with advanced technology and all the space-related studies we have conducted, scientists are still searching for an answer to this question using the scientific knowledge accumulated so far. For example, the European Space Agency's Gaia mission measures the positions, velocities, and chemical properties of billions of stars with extremely high precision. Thanks to the data obtained by the Gaia mission, astronomers are carefully searching for the Sun's sibling stars. Stars born from the same cloud should have similar chemical element ratios. For example, elements such as iron, silicon, carbon, and rare earth elements act almost like an identity card for this possibility. Later, planetary scientist Konstantin Batygin and other researchers attempted to calculate possible birth regions by modeling the Sun's galactic orbit backwards in time. However, there was something that confused scientists and possibly caused large deviations in the calculations. Over 4.6 billion years, our Sun has completed approximately 20 orbits around the center of the Milky Way galaxy. During this time, something called galactic gravitational perturbations scattered stars in every direction in a chaotic way. In addition, the Milky Way itself is not a static structure. The Milky Way is a barred spiral galaxy containing massive concentrations of mass and streams of stars within it. In such a dynamic environment, reuniting a family of stars, and especially doing so through backward calculations in time, is extremely difficult, requires great attention, and carries a very high risk of error. However, according to many studies and theories, many scientists accept that the Sun, like many other stars, was not born alone, and that it eventually went its separate way from its sibling stars. When we look at Sun-like stars in the universe, many of them are actually binary stars, and some even belong to systems with more stars. Therefore, it is believed that the Sun probably had at least one sibling star. But as we mentioned, backward calculations are quite risky and sometimes unreliable. Because of this, scientists have also begun to think about the future of the Sun. How will the Sun evolve in the future? How much will the planets around it be affected by these changes? And perhaps most importantly for us, how will Earth be affected? The Sun is currently in a stage called the main sequence phase. Hydrogen fusion in its core continues in a stable way. However, every billion years the Sun becomes about 10% brighter. This means serious problems for Earth may begin to emerge. In about 1 billion years, the Sun's brightness will increase as mentioned. As a result, Earth's oceans may begin to evaporate, and life on Earth would be severely affected. We might only be able to keep aquatic animals alive in special environments and allow their species to continue in those limited areas. However, gathering all aquatic life forms would be almost impossible. For this reason, most aquatic species would likely disappear. Only species that attract human curiosity or could be used as food sources might remain. After about 3 billion years, the Sun's brightness will have increased even more. According to analyses and predictions, from that point onward, life on the surface of Earth may become impossible. Finally, after about 5 billion years, the Sun will begin to exhaust its fuel. Hydrogen will be depleted, the core will shrink, and the outer layers will expand. Our golden Sun will transform into a red giant. Even though life on Earth will have already disappeared and the planet will be approaching destruction during this stage, the real destruction for the solar system actually begins after the Sun becomes a red giant. This is because the Sun's diameter will expand to hundreds of times its current size. Mercury and Venus will certainly be swallowed by the Sun. Earth will also very likely be swallowed, but even if it is not, it will turn into a scorched piece of rock. After that, the Sun will begin to eject its outer layers into space. The expanding shell of gas will glow briefly, and this structure is called a planetary nebula. Eventually, what remains will be a white dwarf. This white dwarf will be about the size of Earth, but will carry roughly half the mass of the Sun, making it an extremely dense object. object. The cooling of this white dwarf will take trillions of years. When the sun first becomes a white dwarf, its surface temperature will be around 100,000 Kelvin. The cooling process lasts so long that it can be explained like this. Our universe is currently 13.8 billion years old, and so far we have never observed a white dwarf that has completely cooled down. In other words, from a scientific perspective, the universe has never physically tested what happens after the white dwarf stage. Therefore, many things we say about what will happen after this cooling phase are actually theoretical. Anyway, after the white dwarf cools down completely, the remaining object will no longer emit light, will not be hot, and will become invisible. At this stage, this stellar remnant is called a black dwarf. This object will most likely continue to exist until the end of the universe itself. And when we say it will continue to exist, it will have no function at all. It will simply remain as a completely motionless and lifeless object. In short, our sun is a star that most likely had siblings, with a probability of about 90%. However, the conditions of space later separated their paths and sent each of them in different directions. Perhaps right now there are intelligent life forms in the systems of the sun's other siblings who are also thinking about us. Maybe before the sun or earth disappears, we will prove the existence of those stars, and if they host life, we might even establish a connection with the beings living there. Like everything else, time will show us. Yes, dear friends, that's all from me for today. Until our next video, please don't forget to subscribe to my channel, like my videos, and share your thoughts in the comments to support me. See you in the next video. Goodbye.